Okay, hello everyone. Welcome to Module 4. All right, so we're going to continue our discussion here. I have a couple of relatively short lectures for you here in this module, and we're going to continue on our discussion here with sea level rise and some of the concerns. So as we go through this, I want to show you some images here. All right, so I'll get to that in just one second. But I want to just have you look at the outline here for a minute first. Sea level rise, of course, is probably one of our biggest concerns with respect to climate change and certainly global warming. So when I asked the rhetorical question, what is a major threat from climate change? I would say one of the biggest, of course, is sea level rise. Now, there are other things out there, of course, like more extreme weather, more extreme heat, more extreme droughts, things of that nature. But certainly, because we're human beings reside, generally speaking, you'd have to say sea level rise is right up there as one or two, okay? So what I'd like to do is kind of show you a couple of things here on a map that will kind of illustrate what we actually see taking place. So let me get to this here. Okay, there we go. One thing that I'd like for you to understand, there's some very key important elements here with this. If you take a look at this map, I'd like for you to be aware of that about 1 billion people on this planet live at or below sea level, all right? If you have not traveled much around the globe or, even here in the United States, if I come over here to places like New Orleans, Louisiana, and continue around the Gulf Coast out towards Mississippi and Southern Alabama and places like that, New Orleans actually sits below sea level. It sits about 8 to 10 feet below sea level. So when they have tropical events, when they have hurricanes, their inland flooding is phenomenal. That is very true along the Gulf Coast of the United States itself. If I come up here into Northern Europe, and especially if you ever go to a place like Holland, you see the windmills. The windmills are largely to pump the water away, to try to get rid of water. So people that live in Holland, they're at or below sea level as well. Big chunk of Asia, especially Southeast Asia, if I come out here, come down here towards Indonesia, these are very low-lying lands. So any fluctuation, any rise in sea levels could obviously pose a major threat to their existence. Now, that's about 1 billion people reside at or below sea level. But if I kind of move maybe 100 miles away from the coast, I have about 3 billion people. So I want you to think about this. If you and I were to go over, say, to San Francisco, let's just use that as an example. We get in our cars and we drive about 100 miles away from San Francisco towards the east, you'd end up pretty close to Sacramento, okay? So if you think about that distance, it's really not that far. You have to sort of keep in mind here that if I go around the globe, about 3 billion people live within that proximity, that distance. Now that poses a major threat, all right? So again, if you sort of look at the global distribution of population, what I'm trying to get you guys to understand is that most of us around the world live within 100 to 200 miles of the coast. That, of course, is that as we see sea levels rise, that poses a serious, serious problem, okay? So let's go ahead. I'll go back to the lecture outline here. So what I'd like for you to know here, when I say a few items, I want you to know that certainly that more than 1 billion people live within at or below sea level. That's the first thing. The second thing, of course, is that we know that if we go about 100 miles in, more than 3 billion people live within that range, and much of that area tends to be low-lying as well, at sea level or a little bit above. It's not that high, generally speaking, okay? And what I also want to point out to you, and I'll get into this a little bit more later on, it's only been since the early 1990s that we've actually seen a significant rise in sea level, all right? We saw it rise before, but over the last, say, 30 years, give or take, 30 to 35 years, we've seen that go pretty, high up, all right, in terms of the rise of sea level. So once again, I want to talk to you about a little bit more about some other proxies. I talked to you a little bit about coring of the ice in the Antarctic area. We also core sediments in the ocean. We can also core trees. things of that nature. But I want to point out to you, there's some other proxies that are used to really sort of monitor the rise and fall of sea level. Okay, that's really not what ice coring does. That's not really what dendrochronology does. So I want to show you a few things here. One of the first things, of course, we use is what is called satellite altimetry. Altimetry is sort of the height above the horizon or the height above the surface. All right, and so let me just kind of show you an example of some of the altimetry that we actually use in sort of studying some of this stuff. So what has happened here is that the federal government uses a lot of different satellite imagery. As you know, NOAA, the National Oceanic Atmospheric Administration, NASA is part of this. There is a system that came out in the early 90s, and it's referred to as TOPIX or JASON, okay? Sometimes it's also called Poseidon. And what happens here is that you'll notice that we have these satellites, and so you notice their TOPIX, Poseidon started in the early 90s, continued on up. We had JASON 1, JASON 2, JASON 3. All right, and these satellites become more new and improved. They're more, they're able to detect things a little bit better. You know, it's just the advances of the technology that we have. And what it does is that to sort of look at this image here, what it does, it sends a beam down to a shortwave beam down to the ocean surface. And when it hits the surface of the ocean, of course, it bounces back and it's recorded that distance that we actually see. And typically what happens with this is that this data is collected about every 7 to 10 days. So we have a real good catalog since the early 90s of sort of the rise and fall of the oceans around the world. And so it's constantly monitoring this, providing us with new data, all right? And what we've actually seen with this that I want to point out to you, since about 1992 to present, we've actually seen a rise of sea levels of about 2 inches. Now, again, the key thing, the most important thing with this, of course, is the idea, you know, with that 2-inch rise, that water's got to go somewhere. And I mentioned to you in a previous discussion that for about every inch that the sea levels rise, we lose anywhere from about 8 to 10 feet of land. So if it is true that the sea levels have risen a couple of inches over that since 1992, well, then we know we've lost anywhere from about 16 to 20 feet of land. That's pretty significant. That's very significant, of course, if you live at or below sea level. All right, so that becomes a very important part of our discussion. Now, what also takes place with TOPEX is that what also will happen is that not only is it sort of measuring the ebb and flow, the rise and fall of the sea level, but what it also able to do, it takes a GPS unit, and the GPS unit is pretty darn accurate. It's actually accurate up to about 2 inches, and what they're able to monitor is where do we see the greatest rise, where do we see the greatest fall. And over that period since 1992, there's been more rise than there has been fall. And so that is one of the things that we have been able to collect and to come to understand with sort of the warming of the oceans, the melting of ice sheets on land, glaciers on land, whatever the case may be. The other thing that I want to point out to you, what is also used, and this is used heavily around the world, and these are sort of what are called wave meters. And so again, if you ever go on a cruise and say you're out in the Atlantic or you're out in the Pacific, you sort of see these things. These can be tide gauges, they're wave meters that sort of take place. And what it does, it measures the rise and the fall of the tide as well. And I think you can see it just sort of floating along on the ocean surface. And what it's trying to figure out, of course, is that, you know, how much are we staying within average rise and fall? So when we look at something like this, this becomes very important for us. And it's just collecting data that's going to be sort of averaged out, okay? And so what we actually have seen with this is that if you look at a map of the global tide gauges, this is actually monitored more by the World Meteorological Organization than, say, NOAA or NASA or anybody like that. And I want to explain to you what these little dots mean here. All right, so you notice that the green dots, this data is updated every 5 years. Sort of that burnt orange, I'm not quite sure what that color is. You know, it has some of the data. The white doesn't have a whole lot of data, but I want to point out something to you. The areas that you see in green, we know that these areas are detecting a rise in sea level. So let's just go ahead and kind of bounce around geographically with this. So we can come up here along the Aleutian Islands in Alaska, make our way down along the Alaskan coast, the Canadian coast, British Columbia, make our way down along the west coast of the United States, and we know we've seen a rise in sea levels. We also, to no surprise, of course, anywhere along the Gulf Coast of the United States, down around Florida, and then continue on up the east coast of the United States, going all the way up here into Canada, we see a rise as well, okay? And again, this is just sort of the ebb and flow and the consistent rise that we see. But you'll notice out here, you know, I come along the west coast of South America, come up the east coast, you see some pockets. So anyway, you can kind of look at this geographically, but you'll notice not only quite a bit here in North America, but take a look at Asia. Take a look at Australia. You know, take a look along Indonesia here. You have to understand that Asia is the most populated region in the world. And so many of these people live at or below sea level, or, you know, not much higher than sea level in general. So geographically, what I'd like for you to see is that Asia is heavily influenced by this. We see parts of North America influenced heavily by this. You know, you do see some places here, you know, in Africa. So you can kind of use your imagination to look at this, but even look at Northern Europe. Okay, if I come up here to some of the Scandinavian countries, all right, we see this. And so these tide gauges are monitored by the World Meteorological Organization. And you'll notice, not only do they have them floating just sort of in the middle of the ocean, but you'll notice a lot of these are relatively close to the coast. And of course, that's where we're most concerned about, you know, the rise of sea levels as a whole. All right, so these, I just want to point out to you. So, you know, TOPEX, you know, it's just simply sending down a beam, bouncing up, you know, and of course, the shorter distance of the return, that means that the oceans are rising. But you also see these tidal gauges that can see these swells, these ebb and flows, but also where we see sort of loss of land with this, okay? All right, now, the next thing I want to point out to you, if we go back to our outline here, is that you see these tide gauges, you see the satellite altimetry, but one of the things that we're also very concerned about is what is taking place in the Pacific. Now, why the Pacific? Well, first of all, this is our largest ocean. And you have to understand that if you look at sort of the distribution of global population, I mentioned to you that, of course, Asia is the most populated region in the world. Well, that sits predominantly along the Pacific, right? So we look at this, and that's why this gets a fair amount of attention, all right, that is taking place. And what this is called the Pacific Decadal Oscillation. So decadal, every decade, so every 10 years, they're sort of looking at some of this stuff, okay? Now, there is a linkage between El Nino Southern Oscillation and the PDO, or the Pacific Decadal Oscillation. So let me go back to our map, and I just want to point out something to you with this. Okay, so I brought this back up because if you sort of look out here in the Pacific, so here's the Pacific here, and the Pacific is over here. All right, we sort of look at this, and what we know is that we are seeing a warming trend that is actually taking place. Now, if I go back here, and we talked about the fact that we have cool running water up here along the coast of South America, and then it comes up along North America. And then out here, we have a tremendous amount of warming in these currents. Well, what we do know with respect to this is that we do see this warming taking place, sort of an accentuation of El Nino that has been taking place for quite some time, okay? So in some pockets of this, we actually see sort of a warming of temperatures. You see a recession of glaciers, okay, meaning land glaciers that are melting into the oceans, providing more liquid water, all right, to the oceans, if you will, with this. Now, one of the things that is very, very important with us is that when we see oscillations, so you guys should know that oscillation, of course, is that it sort of oscillates. We have periods of warming, periods of cooling, things of that nature. Now, why are we interested in this in many parts of the globe? Well, there is a little bit of a pattern that we actually see that will sort of tie in all this together. In 2011, we had probably the worst tornado season in the United States. Tornadoes are predominantly a United States phenomenon. Other parts of the world get tornadoes, but nothing to the extent that we do in the Midwestern United States. And one of the things that we have seen with this is that, remember, if climate change, global warming is taking place, there seems to be sort of an exaggeration, an amplification of things, more intensity taking place. So one of the things that happened is we saw significant cooling of the Pacific, all right? So remember, we said we got these periods of warming, periods of cooling that take place. And when we saw this cooling that took place in 2011, it was followed by one of the worst tornado seasons ever recorded in US history. The other thing is that there appears to be somewhat of a correlation too of cooling of oceans and the accentuation or the more intensity of hurricanes as well. We've seen this sort of parallel, all right, when we see this. So what I want you to know is that when we look at this, when we see sort of a cooling taking place, we tend to see a more intense outbreak of tornadoes and hurricanes. When we see more of a warming, it seems to die down a little bit. But in places that are not used to getting a lot of precipitation, that would be like us here in Northwest Nevada. We also see in Southern California, we tend to see a lot of challenges, a lot of problems sort of unfold with this, with more rainfall, things of that nature, okay? So there is this linkage between, this ENSO and Pacific, decadal oscillation. And this is what sort of TOPEX, what our wave meters, what all of our gauges and everything is trying to collect this type of data, okay? So when we look at this, we know also that what takes place is, I'd like for you to see this. This actually comes from TOPEX as well. And I want you to understand is that what is accelerating a lot of this change in sea levels is obviously warming, but it's also that loss in Greenland and Antarctica, okay? And what is called the thermal expansion of the oceans, okay? So when we actually look at this, I want you to look at this graph. So here we are, we're going back to 1880. And if you recall, I asked you before an assignment, why 1880? Because this is when we started to sort of really collect more weather data. Prior to that, it was rather sketchy. So down here at the bottom, we're going by year. Up here, we're talking about how much the sea levels have risen. And it's done in millimeters, and I'll explain this to you in just 1 second. So what we do is we know we've had tidal gauges for quite some time. So in terms of this oscillation, so you see some years, okay, we see more amplification. All right, things tend to drop a little bit. We're talking about sea levels. But you'll notice I get up here towards the 1990s when we started to use the altimetry. So a lot of TOPEX. So the red here is just so when we started to use this as well. But you guys will notice the satellite imagery and the gauges parallel essentially one another for the most part, okay? But I want you to notice this phenomenal rise. So here I am back in 1880. I come all the way up here 140 years later, sort of maxes out around here around 220. So I've gone from 0 millimeter rise up to close to 250 millimeters. Now, what is that in terms of our units? That's just under 10 inches. So in that 140-year period, it is believed that the sea levels have risen by about 10 inches, give or take. Now, once again, let's do the math with this. If the sea level has risen by about 10 inches, that means that we have lost close to 100 feet of land. A little bit later on the semester, I'm going to ask you to watch some videos about what's taking place in Louisiana and in Florida, and you'll see how much land they've actually lost, okay, in more recent times with this. But I want to point out to you, and I want you to look at this, image here for a minute. And what I tried to do is that thermal expansion of oceans. So When something gets hot, of course, it expands and rises. But the key thing is expansion. So one of the things that we also see with this is that the idea is here is that if the oceans are expanding, so the heating, that means that the atmosphere can hold more water. And so what happens here, more heat, more evaporation, the higher carrying capacity, that means more intense weather, especially things like rainfall. So you already know that a monsoon is a wind, and we have the wet monsoon and we have a dry monsoon. Much of Asia is heavily influenced by this. Yes, we have places like Arizona and southern Nevada get hit with the wet monsoons. But I want to point out to you is with this thermal expansion, that means there's the ability to hold more moisture. The ability to hold more moisture means more intense thunderstorms, more intense weather, heavier precipitation. And that is what is sort of forecasted for many of these low-lying areas, especially where there's a surplus of heat and where we actually see this, okay? So this is why this is very important with us, why we actually see this, okay? All right, so let's go back to the handout here real quick and I can wrap this up then. All right, so let me go to this. Okay, so what I want to point out to you, there are two very key factors with this that I'd like for you to all understand. All right. If I look at this and I have the melting of, we've lost a tremendous amount of ice sheets, we've lost a tremendous amount of glaciers, okay, over the last, say, 140 years. You look at this, about 80%, okay, of a lot of the snow and ice is melted. That is what has accounted for the rise in sea level. All right. So this is the key thing. I know I've said this to you before, but I want you to make sure you understand this. It's the loss of land ice and snow that we're most interested in this. And this is accounted for the bulk of the sea level rise. This is the first thing. The second is that, of course, with this thermal expansion and the rise of water, what becomes very important, the water expands, creating more evaporation, and this creates more intense storms. This is very important for us to understand. So it has been since about 1992, give or take the early 1990s, that we've actually seen about a 2-inch rise in sea levels. That is very, very significant. And this is going to sort of translate and sort of use as a segue here in the next couple of modules, where you're going to see the tremendous amount of loss of land, especially here in the Gulf Coast of the United States. Okay. All right. So I have another short discussion for you in our next lecture. Okay. So again, as always, if you have any questions or comments, please let me know. Okay. So have a good day. Take care.